In this exercise, we're going to discuss guidelines for dimensioning sketches. Applying parametric dimensions in Inventor is pretty straightforward. Because you use a single command, there's not a whole lot of choice. The software does everything for us when choosing a linear, angular, radial dimension. If you follow a couple simple guidelines, you can ensure that dimensions are properly applied to your sketch. Like I said in previous lessons about geometric constraints, you want to make sure that you use constraints first because we're trying to stabilize the shape before we stabilize the size. Then we're going to make sure that we use constraints instead of dimensions whenever possible. So for example, over here on this rectangle, you'll notice that the top left point and the bottom right point are the only two dimensioned. The bottom left and top right, if we take a look at our constraints, are actually using horizontal and vertical constraints to the dimension ones. So by doing this, I can eliminate 4 dimensions. So whenever possible, I try to use these constraints to lock in the size and shape of the object. A similar issue would be if you were using angular constraints for perpendicular or parallel. That allows you to lock in the same thing. We have parallel here with a horizontal, and then we have perpendicular here, instead of doing a dimension with an angle. You could still use a dimension for a reference, as I said in previous lessons. It's a good way to check to make sure that you are at 90 degrees if you forgot to put it on there or something. But whenever possible, I do try to do perpendicular, parallel, horizontal, vertical. Try to make sure that I use geometric constraints as much as possible. The next thing to remember is to place a large dimension before you place small dimensions. I noted that in Inventor 2013, they gave us the option, if I turn off my constraints here, that it automatically scales the first dimension put on a sketch. Now I already have other sketch objects in this drawing. So what I'm going to do now is I'm going to finish this sketch. I'm going to save this. So I go up to the top and I click New. Then I click on the standard IPT, create. I'm going to create a new sketch. And I'm going to do something that's kind of notorious for inversions. And you'll notice that my constraints are probably hideous. There we go. And then I'm going to put a dimension on this. With the 2013 allowing us to scale up, you'll notice that it kept everything exactly as it was, the way I wanted it. But I still want to really put my largest dimensions on here first. Because if I come in here and I put this dimension on, you can see that some bad things can happen. I could also get inversions sometimes where it will accidentally go inside out. If I come in here and clean this up a little bit here. I'm trying to make it nasty here on purpose because I'm trying to show you what happens. If I put a dimension on here. There you go. You can see that it actually will invert on itself. This is because I put the smaller dimension on before I put the larger dimension on. So the best practice here is to use the dimension command and start from the outside in. Start making the larger dimensions on there. Ideally, you're going to want to make sure that you have things such as horizontal and vertical constraints locked in. Have all your coinciding constraints locked in. Then whenever you start adding dimensions to it, for the smaller dimensions, it's going to control the shape along with the size better. So what we want to do is make sure that we do the largest first. Even though Inventor will scale it up for us, we want to put that largest dimension on before we start putting on these smaller dimensions. Always a good idea. We want to incorporate relationships instead of using multiple dimensions to do the same thing. So for example, if this top beam's 1.5 and the bottom beam's 1, instead of typing in 2 separate dimensions, what I could do is I could say this dimension minus 0.5. I get the same thing, but if for whatever reason I need this to scale up, now this goes up to 2 and this goes up to 1.5. If I need to break this from this really needed to be 1, I can always come back and manually type it in. But I want to think about relationships that I have like this. So any kind of relationship that you have that you can put in there and say, this is 1/3 or, this dimension minus 0.5 inch. You want to add those relationships into your geometric dimensions. And then you want to consider both dimensional and geometric constraints to meet the overall design intent. Like I said before, we want to add the perpendicular in there and parallel and things like that. But there are going to be times when you need it to be 75 degrees. So therefore, you're going to make sure you don't do a perpendicular. But you want to make the bottom of the angle to be horizontal. So you do want to remember both of those are very useful tools, and you want to use them with each other. So they're not mutually exclusive. And then whenever you get done with everything, if you just want to see the best way to lock it down, we can come up and we can use the automatic dimension tool as a quick way to check. It'll actually let you separate out dimensions and constraints. We could say apply, and you can see how Inventor would automatically add that in there to lock that down. You can also use the automatic dimensioner to remove constraints that you've added with the automatic dimensions. Auto dimension is really good just to lock things down. It's not necessarily something you want to use for your dimensions, but it's a good way to give you a feeling of how Inventor suggests to do things. It's also a good way if you can't figure out why something's locked down. One more little quick tip. If you get everything locked down size and shape wise, and it's still not turning black, and you can't figure out why it's doing it, see here it's telling me, okay, this is all good, this is good. I can constrain the heck out of it. And it's still not giving me black lines. More than likely, it's because you're not constrained to the origin point. If you try to drag your part around or your sketch around, you can see that it's actually going to let me drag it around, but it's not locked down to this origin point. You can either use the dimensions. I like to use the horizontal and vertical constraints to lock it into place. So I put a vertical to the center point and vertical to the center point, and now I get a good fully constrained sketch. So if you want the center point to be there, if you have some offset center point, then you could use a dimension instead. Back up, and I could say dimension this line to the center point, enter it in. So now I get a fully constrained sketch. So we always want to make sure we have a fully constrained sketch whenever possible. If it is going to need to be adjusted or adaptable later on, we can leave it slightly unconstrained, but I highly suggest you don't leave it just floating in space. I'm horrible about remembering to do this myself, but whenever possible, try to fully constrain your sketch. And then, once again, keep it simple. If you can put fewer dimensions on there and more constraints, you're better off. But try to keep it as limited as possible with both constraints and dimensions, because those will make your life easier whenever you go to edit this later on. You always think, oh, I'll never come back to this sketch. Once I create it, I'll be done. But there'll always be something you'll need to come back and do. So try to make sure that you limit the amount of dimensions and constraints and do it as few steps possible. One of the things I always tell my students is whenever you dimension something out in a sketch now, go back and look at it a year from now, and you'll laugh at how much you've come in a year's time because you'll use so much fewer just from experience. It's one of those things you need to play with and get good at. And that's pretty much it for the basic guidelines.